displacement and double displacement reaction. This is type 4, number 4, and this one is type 5, the double displacement reaction. So here I got these pictures from Google, and if you look here, this A by itself, this is a general equation for single displacement. A by itself means it's an element. I'm going to write letter E for element. B and C together, it is representing a compound. So letter C is for compound. B by itself is an element, E, and A and C together is representing compound. Okay. Similarly here, you have this general equation: compound, 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 and compound. So if you look carefully here, the difference between the single displacement and double displacement reaction is you have only one compound on the reactant side, and here you have both of them as compound, meaning two compounds. Now how are the products formed out of these reactants? That's a different lesson, so we are not going to focus on that. Our focus is mainly the identification. Okay, so if you are given a chemical equation, how can you identify if it is a single displacement or the double displacement? Okay, let's take an example here. Alright, so if we look at this picture, this is like, this one is the better dancer. These are dancing here, these couple, and this comes a better dancer. This better dancer removes the one that is not dancing that great. And similarly, this is a case in compounds. So this is a compound. Here it's making a compound, and this element, which is actually stronger or is more reactive than B, this displaces this element B from BC. But again, that's not our focus right now. Our focus is just to identify the reactions. Okay. So I'm going to put it like this. This copper is more reactive than silver. So this displaces silver from silver nitrate solution. That is how you get the products. But let's just remain focused on the identification part. Look at the reactant and the product side. On the left side, this one is an element. Okay, and here this is a compound. How do we know it's a compound? Because compounds are made up of two or more elements that are chemically bonded. So it is silver nitrate. This is an element. This one is a compound. So on the left side you have element and compound, and so on the right side you have element and compound. Let's look here. This one, an element, aluminum. This one is a compound, C, letter C for compound here, copper chloride. And here aluminum chloride compound, and copper is an element. So it doesn't matter whether you write element first or compound first, or here same thing, you could have written that first or that first. But what matters is, in order to identify the reaction as a single displacement, you have to look for that you have an element and compound on the reactant side, and you have an element and compound on the product side. Okay. Let's do the double displacement reaction. In this reaction, you have AB, it's a compound, CD is representing one compound, AD is representing another compound, and C and D is representing another compound. So this reaction happens when cations, they exchange their places. So atoms or ions, when they exchange their places, then occurs the double displacement reaction. But again, the focus is to identify how do we tell it is a double displacement reaction. So here, this is a compound, lead nitrate, potassium iodide, a compound, lead iodide, a compound, potassium nitrate, a compound. Now they all are compounds. So on the left side compound, right side compounds. And also another thing to notice, this is an ion, lead ion, nitrate ion, two ions. Similarly here, potassium ion, iodide here, ion. So all these compounds here, they are in the form of ions. They are representing actually ionic compounds. So here same thing, ammonium ion, sulfate ion, barium ion, nitrate ion. And this is a compound, this one is a compound, here compound, and here compound. So what did you notice? You noticed that if on the reactant side, meaning the left side of an arrow, if you have all of them compound, both and on the right side as well, they are all compounds. So no elements at all in double displacement reaction. That shows it is a double displacement reactions. And you can see here these ions, since they are ionic compounds, they are switching the cation part. Another name of this double displacement reaction is metathesis. Okay. Let's do the quick summary here. I want you to just read it quickly. All right, and let's go work on the exit ticket. You can refer to the summary chart. So here, the first one is potassium iodide and bromine, and then you have potassium bromide, and then you have iodide here. Now this one, potassium iodide, is a compound, bromine is an element, okay, and this one, potassium bromide, is a compound, and iodine is an element. So you're going to look here which category does it fall into, and if you look here, single displacement, you have elements and compounds on the reactant side, elements and compound on the product side. So this is our single displacement reaction. Okay. Now this one here, a compound, a compound, a compound, a compound. So we are again going to refer back to our summary chart, and double displacement, both compounds on the left side, both compounds on the right side. So this is our double displacement reaction. Double displacement reaction. Here you have only one product, and also you have oxygen on the left side. So let's see. If you have single product, it is synthesis reaction, and if you have oxygen as a reactant, it is combustion reaction. So this reaction is both. This is synthesis and combustion both. Okay. Also, synthesis reactions are usually exothermic. They release the heat energy. Now here you have only one reactant. So let's see, where does this one fall? The single reactant falls under the category of decomposition reaction. And here I have written in the summary chart that decomposition reactions are usually endothermic. So endothermic means they can absorb energy as a heat or the light or even the electricity. Like here in this case, this is electrolysis of water. So this is using electricity as a source of energy. And this is your decomposition reaction. Now let's look at the last one. Last one, we have carbon dioxide and water as a product, and we have oxygen as a reactant. Let's see, where does this one fall? Look at the combustion reaction. Oxygen as a reactant, water and carbon dioxide as a product, and that is a combustion reaction. So this is a combustion reaction of butane. Okay, this is a butane gas. This one. I hope this helps. Thank you.